Okay, so I'm finally getting around to writing the first part of the second unit, introducing people to sockets and packets. I'm not going to be doing anything advanced in this section. I'm just going to be basically going over what packets are, what sockets are, how they work, and we're going to write a very, very basic communication program to sort of demonstrate those examples. Unit 2, Part 2 will go into actually logging and understanding packets from Conquer, and then we'll move towards actually using them for a botting system. But for now we're just going to basically be doing the background, and again, if you understand all this already, you can wait for the next unit, or you can follow along and correct me in all my mistakes. If you've read through the little companion here already, I basically go over like what bytes are, how packets work, how they're sort of structured as sort of chunks of 1, 2, 4, or 8, or counted bytes, such as in a string. What I'm going to do though is we're going to write a very, very basic we're going to be writing a synchronous socket program. We're not going to be delving into asynchronous. The difference between the two is basically how efficient they are and how well they work. Synchronous is very, very simple to demonstrate though, so we're going to start with that. So we're going to create a new console application project just because we don't need anything fancy. I'm just going to call it Unit 2 Part 1. So as always, we have our program.cs. We have nothing in here, so what we need to do is we're going to first set up a server. So I'm going to actually rename this part to server. And we're going to do two. We're going to add another project and call it client. So now we have our two there. We can sort them out and we can do whatever we want with them. So first step is we have to listen on a socket for our connection. This is really, really simple to do in the basic sense. If you look at the sort of companion for the video, we're going to create a new project. We're going to bind a server socket and then connect a client to it. We're not going to be dealing with supporting multiple users, advanced error reporting such as stability or error catching. We're not going to worry about efficiency or threading. Right here, we're just going to basically be able to send a packet and confirm that it got there. Again, this would not be useful in an actual server application, but it gives you an idea of how things work and how you can set them up. As always, we need more using statements, in this case using system.net and using system.net, net sockets. That's all we really need for the socket communication aspect. Again, we don't need anything advanced for this. We're just going to set up a socket to listen on. So we're going to do socket listener equals new socket, and we need to enter the parameters for it. In this case, we're going to do address family internetwork, which basically means it goes between networks, which is pretty obvious. Socket type stream, protocol type TCP. Again, this is just what I'm using. They all have different options for different applications and uses, but this is the most common application for what you'll be dealing with Conquer. So we need to then bind that listener to an IP endport. So if we try and do listener bind, you'll notice that we need an endpoint, which is a local EP. So if we do IP endpoint, actually we need a new IP endpoint, which would make more sense. We can then do IP address and port. In this case, IP address any. Port, I'm just going to go with 1337 because I don't care. Listener, I think it was listen. Backlog is how many pending connections in a queue. I'll do 100, but as I said, we're not supporting multiple users right now. We're only using one. So we have that set up. I'm going to load my cheat sheet here because I don't want to mess this up and have to go back to it. So what we're going to do is we're going to actually set up a socket to receive a connection. And to get that connection, we need to take our listener and accept is what we want. So accept will block off this connection. That's the thing with the difference between synchronous and asynchronous is they block off a thread. So in this case, nothing else will happen until we accept a client. Until we accept a client, nothing else will happen. For example, console write line done. Oh, it would help if I could hit my shift key. Again, I'll want firewall access. Notice, it never writes out done because no one's connected yet. That's the issue with synchronous. They block off an entire thread, and until they succeed at what they're trying to do, nothing else can occur. This poses an issue when you have, say, 100 clients all trying to receive and send packets. You have to block off a thread or block off that connection until it receives the action it's trying to do, such as accept or receive. That's why you might have heard of the thread per socket or thread per client model, which is what, say, COMU did, where there was at least 1 or 2 threads per user just trying to handle receiving packets and everything. This poses an issue because by default threads run at 1 megabyte of RAM each. So you can quickly run into large amounts of RAM usage just trying to sort of handle things properly. So anyways, at this point we have accepted a user, and I'm just going to say if connection connected, console write line user connected. I always like to have a read line at the end of my consoles just because it keeps them from closing if it reaches the end. So in this case we're just going to set up a simple loop to constantly try and receive a packet. So I'm going to say byte buffer equals new byte 1024. This is going to be our client buffer. We're now going to set up a simple loop to try and receive into that buffer. Alright, so we want our connection to receive. Now we have a few things that we can do here. We can add all sorts of different things, but what we're going to do is we're going to receive into the receive buffer. I believe this will let us just do socket flags none. That just handles error forwarding. You don't need to worry about it. It's just what I'm using. And I'm going to say if length is greater than 0 and length less than 1025, so that way it'll fit into our buffer and we know it's not empty. We're going to say, crap, I want it in the receive buffer. Sorry about that. So receive, we're going to instantiate into a new byte with the length. And that way we can copy into it using array copy. You could also use buffer block copy, you could use pointers, you could use a loop, you could use whatever you want. I'm just using this because I have it handy and I don't care to look into more advanced things. So source array is going to be what we received into, in this case, buffer, which is already created. Length is already there, and receive we've just set up. So receive and length. So I'm going to say console write line receive packet, console write line, and here we're going to use something called get string, which will get a string from a byte of arrays. It'll try and convert it all into string, which is exactly what we want in this case. We're not going to use a structured packet, we're just going to use a big long string. So we are going to take receive and write it out. I'm actually going to add a tab in here just so it looks all nice and sexy indented. So this is our first server. We need something to connect to this server though, so we're going to go over to our client, and again we need using system.net sockets. So we're going to create a new socket, and again we want address family, wrong one, internetwork, socket type, stream, protocol, TCP, again just because that's what we're using in this case. And we can now use connect, and in this case we want a string host, in this case 127.0.0.1, and we want the port for the host, which we set to 1337, or if I could type today, 1337 earlier. So this should attempt to connect. Now, I'm going to just write in a few little things here so we can keep track of which is which. Console write line, client starting, and in the server, console write line, server starting. Now, I'm going to say if connection connected, console write. I'm just going to say while connection connected. And what I'm going to do is say string input equals console read line. And then I'm going to say connection send encoding si get bytes input. So there we have it. That should be our very first. Oh, I don't know if I didn't have that as a colon semicolon. Yeah, so that should be our very first to server trying to accept a connection and then accept packets from that connection, and we're just simply writing them out. And this is going to accept input and send it as a packet because we're using get bytes. Now, a very useful thing is we can go into the properties for the entire project and set startup projects, multiple, and we're going to run both of them because I don't want to have to run them separately. So, server starting, user connected, we're ready to send packets, test packet, receive packet, test packet. Now, what we're going to do is notice I didn't have any lovely error handling because it's forcibly closed by the host. We don't need to worry about that because, again, this is not designed for an actual solution. It's just it's what we're using for now. So yes, that's our very first idea of how to do things. Now, what we could do is we could write structured packets like TQ does, where they have generally they have a U short indicating length, they have a U short indicating packet type, and then the rest of the packet. We could write things like that, but again, I'm not going to delve into anything advanced for this unit. I'm just going to be going over the basics. So I'm going to leave it at that for this little video and just basically let you guys see this is how you can set up a very basic socket system. It's nothing worth using in an actual program, but it can give you an insight into how to do things. For example, the server here, when I receive this connection, I could start a thread to basically do this, but only for that client, and then just keep letting new clients connect. I could also write a server class here that when I start up the server, I basically saying server listener listener equals new server listener, and basically pass a whole bunch of parameters, say like port 1337, backlog 100 users, or something like that. Like I could do this all as a very not advanced, but workable system, and it would actually provide a decent system for using. But again, we don't need it. It's just an example. Anyways, hope you guys enjoyed this, and you can look forward to structuring TQ packets in the next little video.